solve it. Okay, I will, you see that, okay, and reason them and try to understand why and where it came from. Okay, the circuit is contained of one this sort. Okay, the sort, you can see that the sort is comprised by the unit step function. It means for time less than 0, this voltage sort equal to 60 volt. But for time greater than 0, it equal to 60 minus 40. It means the sort, it will be smaller, right? The sort is more inside. It changed from 60 volt to be 20 volt instead. Okay, therefore the current and the voltage at every point will be dropped to certain value. The circuit is comprised by R, the resistance, and the inductance, or RL circuit. Okay. Therefore, the key to determine about the RL circuit for the driving case, you must determine the inductor current for 4 steps. Okay, the first step of the inductor current determination is you determine the inductor current for time less than 0 or before switch is activated. Before the switch is activated, okay, UT equal to 0. Therefore, the sort is still 60 volt. Okay, and this sort is already charging the inductor until it full charge. If it full charge, it perform like short circuit. Okay. Any transient in the circuit die out long ago, revealing the pure DC circuit. Okay. And the inductor perform like short circuit. If it's short circuit, you can see that the circuit, the original circuit in this figure will be simplified a lot. Therefore, the circuit will be comprised by a single voltage source and a single resistor. You can determine the inductor current very easy. V equal to IR, or I equal to V divided by R. Okay, V is the 60 divided by 10 equal to 6 amp. Okay, 6 amp. The next step, okay, the second step is you determine the inductor current at time infinities. Okay, at time infinity is mean after the switch is activated and leave it a very long time. Okay, the switch, okay, in this case, the unit step equal to 1. If unit step equal to 1, okay, this function will equal to 60 minus 40. The result equal to 20. Okay, 20 volt. Okay, if it equal to 20 volt, and if the sort is changed the side to be the 20 volt for a long time, okay, the inductor is already full charge. And we assume that any transient in the circuits die out long ago, leaving a pure DC circuit. The inductor is act like the short circuit to the DC current. It's short circuit again. Now you can compute the inductor current in that situation very easy. Okay, it's equal to, you know, the voltage equal to 20. You know the resistance equal to 10. Therefore, I equal to V divided by R. The inductor current equal to 20 divided by 10 equal to 2 amp. Okay. Now we go to the third step. The third step is you determine the time constant first. And the time constant in this case, you see that the time constant equal to equivalent inductor divided by equivalent resistor. Okay. In this case, okay, equivalent resistor is 10. Equivalent inductor is 50 millihenry. Okay. Therefore, okay, 50 millihenry divided by 10 give you 5 milli. Okay, therefore the general form of the inductor current is equal to inductor current at time equal to infinity minus I e power minus t divided by tau. Tau equal to 5 milli in here, and I infinity, the inductor current at time equal to infinity equal to 2 amp. Substitute them. Okay. After you substitute them, okay, substitute I infinities, okay, the inductor current at time infinity, and tau, okay. Now you already have still some unknown. Here I have, okay. You know that, okay, I for time less than 0 equal to I for the time greater than 0. I for time less than 0, you compute from the 1.1 step. It equal to 6 amp, okay. It equal to 6 amp, okay. Okay, at 1.1 step, it equal to 6 amp. Time greater than 0, it equal to 2 minus I e power minus 2000 t, okay, 200 t. There, both of them, time less than 0 equal to time greater than 0, because, okay, from the third characteristic of the inductor, it is impossible to change the current through an inductor's IL by a finite amount in 0 time. Okay, Both of them is equal. The objective of this step, we would like to determine this constant, okay? This constant value and the I naught, okay? The sign of them, you can see that, okay, it may be plus or minus, don't worry about that, okay? When you substitute them in this equation, okay, you get the sign, correct sign answer, and when you replace them back, it will provide you the suitable sign, okay? The final answer equal to here. The inductor current for time greater than 0 equal to 2 plus 4 e power minus 200t, okay? Okay, equal to here for time greater than 0, okay? Now at time equal to 3 milliseconds, okay, you substitute 3 milliseconds in here, you get the inductor current equal to 4.2 amp, okay? But the questions ask you for more. It's ask you for the inductor voltage, okay? You can derive the inductor voltage from the inductor current directly, okay? Now, for time less than 0, the inductor current is fixed. It equal to 6 amp. Okay, the inductor voltage we are equal to L di dt, okay? The differentiate of the constant equal to 0. Therefore, the inductor current for time less than 0, it equal to 0 volt, okay? And for time greater than 0, okay, the inductor current is not constant. It equal to 2 plus 4 e power minus 200t. Take derivative of this term. Take derivative of the first term, 2 is constant, right? Give you 0, okay? Take derivative of second term, okay? EAT. Differentiate of EAT give you AEAT, okay? About here, AEAT, okay? A. And A in this case, it equal to minus 200, okay? Expand them, okay? You can multiply them, reorganize the form. The inductors voltage equal to minus 40 e power minus 200t, okay? And for time equal to 3 milliseconds, okay? Well, the inductor voltage is equal to minus 22 volt, okay? Now in the overall point of view, okay, for time less than 0, okay, the source is seem to be very big, okay? The source is still equal to 60 volt, okay? Okay, is charged the inductor until it full charge, okay? It perform light short circuit at that time, and the inductor current equal to 6 amp. And at time equal to infinity, okay, the source is changed the sign to be 21 instead. Therefore, the current will be is only, okay, 1/3 of the starting, okay? Instead it's 61, it will be 21. Instead it's 6 amp, it will be only 2 amp soon. Therefore, the current in the inductor will be dropped from 6 amp to be 2 amp, okay? And after that, okay, the shape of the droppings is came from the solution of this differential equation, and it becomes 2 minus I e power 200t is dropped in here. For time greater than 0, okay, that you get in the 1.3 equation, and time less than 0, that it equal to 6 amp, okay? Both of them equal when time equal to 0 at this point, okay? And you can get the constant value. The constant in this case, you get it equal to minus 4, okay? You substitute them, you get the general form of the inductor current, it equal to 2 plus 4 e power minus 200t, okay? For the inductor voltage. For the inductor voltage is here, okay? You can determine them from the inductor current directly. For time less than 0, the inductor current is constant. The inductor voltage equal to L differentiate of the inductor current, okay? Di dt. If it constant, its differentiation equal to 0, okay? 0. In the physical point of view, why the inductor voltage is equal to 0? Because the inductor is already full charge, okay? Because it's already charged by the current source for a long time until it full charge. If the inductor is full charge, it performs like short circuit. If it short circuit, it means it have no voltage across them, okay? The voltage equal to, the inductor voltage is equal to 0, okay? Whether you analyze from the differentiation formula or by its characteristics theoretical, okay, the same. The result is the same, okay? Next one, okay, for time greater than 0, you differentiate L di by dt, okay? Give you minus 40 e power to minus 200t, okay? You can see that in this case, the voltage, the inductor voltage change from 0 to be minus 40 volt immediately, suddenly, okay? And after that, it will be charged and it will be dropped to 0 soon, okay? Drop to 0 soon, okay? This is the overall of the previous assignment. Okay. Now we go to the last topic in this lecture. We discuss another two topics. Okay. The natural response and the forced response and the driven RC circuit in this case. Okay. The natural response. Okay. What about the natural response and what about the forced response? The natural response, it means the response that came from the circuit that you kill every sort, every independent sort. Okay, in this case, such as when we analyze, when it determines the inductor current from the sort-free RL circuit or the sort-free RC circuit. Okay, something like that. Okay, therefore, the complete response that must be composed of the two parts. The first one is the natural response, and the second one is the forced response. The natural response that depend upon the general nature of the circuit, the type of the elements or the size of the element and the interconnection of them. Okay. Sometimes this part we call the natural response is the complementary solution. Okay. The next one is the forced response, okay, that frequently refers or asked by the engineering, okay, called by the engineering's point of view. The forced response, it means the response that depend on independent source. If the independent source will be the sinusoidal waveform, the response will be in the sinusoidal waveform shape, okay, but the frequency may be different, the magnitude may be different, but it must be have the sinusoidal characteristic. Okay, that's why we call them, okay, the forced response. The response came from the force function or came from the source that you feed to them. Okay, in the mathematics point of view or in E-math, okay, we call this response that solve from the differential equation is particular solution. Okay, let us consider the general equations of this type meet the previous section. Okay, therefore the general solution is compiled by, okay, the natural response and the forced response. Okay, that I already teach you, okay, how to solve them. Okay, you can use the previous four step, okay, that already get both the forced response and the natural response together. Now, in order to give you more understand about the natural response or the forced response or complete response, we will show you in another one example. Okay, in the circuit, the RL circuit, okay, that show in the figures 37. Determine and sketch the inductor current, determine and sketch the inductor voltage, and determine and sketch in the 6 ohm resistor current. Okay, for this we consider them, okay, the same as the previous. Okay, we separate them in 4 main step. Okay, in order to determine the inductor current, okay, we determine the inductor current before switch is activated or for time less than 0. For time less than 0, you can see that, okay, for time less than 0, unit step ut equal to 0. Therefore, this sort is 0. What about how to kill the voltage sort? We kill them by short circuit. Okay, short circuit. Okay, and here the 50-volt sort will be feed and supply the energies to all 3 devices until it full charge. Okay, therefore, if the inductor is full charge, it performs like short circuit. We assume any transient in the circuits died out long ago, leaving a purely DC circuit, and the inductor act like the short circuit to the DC current. You can see that, observe this very clearly when it's short circuit in here. You can see that during this time, no current flow in the 6 ohm, right? Because this part is already bypass them, short circuit them. Therefore, you can discard 6 ohm during that time. Okay. The inductor current for time less than 0 is equal to V divided by R from Ohm's law. Okay. V equal to 50, R equal to 2. Therefore, the current equal to the inductor current at that time equal to 25 amp. Okay. For the next one, we determine the inductor current at time infinity. In this case, you can see that at time greater than 0, it have another one sort activate. Okay, the same side. You can see them to be the sort will be bigger from 50 volt to be 100 volt, right? From 50 volt to be 100 volt. Okay, and the same if it's already press, okay, if the sort is already charged the circuit for a long time, you can, okay, the inductor perform like short circuit. Therefore, we assume any transient in that circuit died out long ago, leaving a purely DC circuit. And the inductor act right the short circuit to the DC current. Again, when it short circuit, you can see that in this step is again no current flow in the 6 ohm. You can discard them. Therefore, the inductor current equal to V divided by R, and the voltage equal to 100 in this case. Therefore, the inductor current equal to 50 amp. Now we go to the third step. Determine the inductor current at time greater than 0. Therefore, in this step, you must use, the inductor current and the inductors, the equivalent inductor and the equivalent resistor. Now we see the circuit again. In this case, you can see that the total circuit that you have in this structure form, right? In this structure, okay? In order to determine the way to determine the equivalent inductor is very easy, okay? The inductor current is equal to 3 Henry because it have only a single inductor. But for the resistor, it's different. The resistor is here, right? Therefore, we have 2 resistors. Even though it have no current flow in the 6 ohm during its short circuit, but the 6 ohm is still play an important role in the total response in the time constant. For time greater than 0, okay, both sort is activated, and you Q every sort after that in order to determine the equivalent resistance. Okay, when you Q the voltage sort, you can see that 2 ohm is already short circuit in here, right? 2 ohm is already parallel with the 6 ohm. Therefore, the equivalence, okay, the equivalence resistance equal to 1.5. 2 ohm parallel with the 6 ohm. Therefore, in this case, the solution of them will be here. Okay. Wait a minute. Sorry for this disorder animation. Wait a minute. Okay. 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 Therefore, the tau constant equal to 3 divided by 2 parallel with the 6 ohm equal to 2 seconds. And after that, you can get, okay, you can determine the general solutions form of this by substitutes, okay, the current, the inductor current at infinity and the time constant is here. The inductor current that you determine from the previous is equal to 50 amp and the time constant equal to 2. Okay. Now you get the inductor current for time greater than 0. Okay. For time greater than 0, okay, the inductor current equal to 25. Okay. You can see that for time less than 0, the inductor current equal to 25. For time greater than 0, the inductor current equal to the 50 plus I e power minus 0.5 is T. Okay. Therefore, we take advantage from the third characteristic of the inductor. It is impossible to change the currents through an inductor IL by a finite amount in 0 time. Therefore, the inductors, okay, equal to 25 equal to 50 minus I hat. This objective of this part is to determine of I hat. Okay, you get this constant, substitute the constant back into the general form solution of the inductors current. You get here 50 minus 25 e power minus 0.5 t. Okay, and if the questions ask you for the other parameter, derive them from IL or the inductor current, such as here. The questions ask you to determine the inductor voltage. Okay, for the inductor voltage for time less than 0, for time less than 0, the inductor current is fixed. It equal to 25 amp. Therefore, take derivative of the constant, give you 0. And for time greater than 0, the inductor's current is equal to 50 minus 25 e power minus 0.5 t. Take derivative of 50, give you 0. Take derivative of EAT, give you EAT. A equal to minus 0.5 in this case. Okay, minus 0.5. Okay, after that, distribute them. In this case, you get the inductor voltage equal to 37.5 e power minus 0.5 t. Okay. Now, in another point of view, the questions ask you for the current flow in the 6 ohm. The current flow in the 6 ohm can determine from for time less than 0, you can determine them from the circuit directly. You know that the inductor is short circuit, right? Therefore, no current flow in the resistor 6 ohm during that time. But for time greater than 0, okay, the inductors, the current flow in the 6 ohm equal to voltage across here divided by R, okay? The voltage that you across them, okay, express them in the term of I, and you get here. Okay, you can see that the voltage across the inductor will be decreasing from time to time, okay, until it equal to 25 and it short circuit soon, okay? Therefore, if it short circuit, it mean no voltage across this. If no voltage across them, it mean no current flow in this resistor too. Due to at the time equal to infinity, the inductor is short circuit again. If the inductor is short circuit again, it means all current will be flow in through the inductor part, okay? No current flow in the resistor. Therefore, in here, you can see that the current flow in the 6 ohm resistor equal to 6.25 e power minus 0.5 t. Therefore, if t equal to infinity, I 6 ohm will be go to 0 2. Okay. In the overall point of view, the summary of this procedure is about here. Okay, show you the inductor current for time less than 0, it equal to 25. Okay, and for time infinity, it will be increased. Okay, another one short in here, and therefore the inductor current will be double than the initial value. Okay, and for time greater than 0, it will be increasing in the exponential case, okay, due to the solution from the differential equation is in the term of EAT, okay. Now, after that, the inductor current for time less than 0 and for time greater than 0 is already equal when time equal to 0, and you get this condition, okay, you get this parameter constant, okay. Next one, if you would like to determine the other parameters such as VC, IR, or so on, you can derive from the circuit directly for time less than 0, but for time greater than 0, you must derive them from IR. Okay, for time less than 0, okay, you can see that the inductor voltage equal to the differentiation of the inductor current, okay. For time less than 0, the inductor current is fixed. Its derivative equal to 0. Therefore, the inductor voltage for time less than 0 is equal to 0 2. Okay. Now for time greater than 0, it will become here. And what happened? You can see that the inductor voltage will be decreasing from 37.5 and drop to 0 2. For the last one, for the current flow in the 6 ohm. The current flow in the 6 ohm is here for time less than 0. The inductor is already short circuit. Therefore, all current is go to the inductor part, bypass this resistor. Okay. And for time greater than 0, you can see that for time greater than 0, okay, the current flow in the 6 ohm resistor is equal to VL divided by R. Okay. VL divided by R, you get the currents through the 6 ohm equal to here. Okay, will be the same shape as the inductor voltage. And in this case, it's meaning that, okay, when the time is running after the switch is activated, okay, the inductor is close to be full charge, okay. The more closing to the full charge, the more short circuit of them, okay, until it full charge. If it full charge, it means the inductor perform like short circuit and all current will flow through the inductor part. No current flow in this resistance. That's why make this resistance current equal to 0 soon. Okay. 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 Next one. Okay. Next one, discuss about the driven RC circuit. Okay. In the case that if the circuit is contained by the resistor and the capacitor, and it may be driven by the source for a long time. Okay. When time equal to 0, you may be add one more source. Okay. You may be remove partial of this source, but in the finally, it still have some source in your circuit. Therefore, the current and the voltage at everywhere will be increasing or decreasing to that certain value. Okay. The way to determine the response for the RC circuit, we must determine VC. And for VC, the same as the driven RL circuit, okay, we determine VC at 4 steps. The first one, we determine VC for time less than 0, okay. We ring the capacitor, perform like open circuit, and you use the DC analysis method to determine the capacitor voltage. Next one is close similarly the same as the first one, but in this case, we analyze the circuit at time infinity. Okay, at time infinity. You can see the circuit, okay. You can, okay, if the capacitor is performed like full charge, it perform like open circuit, okay. And after you open circuit to see, repair C by the open circuits, you use the DC analysis method to determine the capacitor voltage, okay. The third one, you determine the capacitor voltage for time greater than 0 by determining the equivalent resistor and the equivalent capacitor. Determine the time constant and you substitute them, you get the general form solution of the capacitor voltage. After that, okay, for time, okay, the response will be in this form, okay. And, okay, even though you get the solution in this form, you get some unknown in here, okay. This unknown, you can determine them from, take advantage from, okay, you set, okay, 1 point. The capacitance voltage at time less than 0 must be equal to the time greater than 0. When time equal to 0, okay. After you get these initials, okay, you apply them. You can see that 1.1 equal to 1.3, okay. In order to determine we have, okay, in here. And determines the other parameters such as IC, IR, VR in the form of the capacitor voltage, okay. Okay. Can I, okay, break 1 minute for thinking, sorry. Okay. Okay, hello, can we continue?
Yes.
Okay. Okay. Okay, in order to give you more understand about the driven RC circuit, I think, okay, we will provide you the example, the real example circuit analysis, okay. From this circuit, determine and get the capacitor voltage, okay. Determine and get the capacitor current and the resistor current, okay. Now the same, okay. We consider for time less than 0 first, okay. You must for the RC circuit, okay, the driven RC circuit, okay. You have 4 steps to solve that I show you in the previous, sorry. Yeah, okay, 4 steps to solve. Yeah, 1.1, 1.2, 1.3, 1.4, okay. Now, to give you more understand, we start by 1.1 for the real case, okay. We determine the capacitor voltage for time less than 0, okay. For time less than 0, okay, at time for time less than 0, is here, the switch is still pressed in this position, right? It's not moved yet, okay. Therefore, it have no contract between two of them. What happened? Yeah, we redraw them, okay. Now the circuit that in this part is already flow by itself. It seems the voltage source is not effect for the outside world, okay. It will be, the current will be flow in here, okay. Now you can, and the capacitor is performed like full charge. What happened to the capacitor that perform like full charge? If it full charge, it means it perform like open circuit. We assume in the transient in the circuits that out long ago, reviewing the purely DC circuit. The capacitor acts like an open circuit to the DC current. Okay. Okay. Now you can see that this circuit is no effect to outside. Therefore, we can erase them. Okay. Now, when you simplify the circuit in this form, it's very easy to observe, right? VC equal to the voltage across 50 ohm. 50 ohm. 1 voltage, okay, contract to 2 resistors that connect in the series structure. Okay. You can determine V50 by apply the voltage divider. From the voltage divider technique, okay, V50 equal to 120, okay, 120. Multiply with the resistor contract to them, okay, 50, and divide by the sum of them. divided by the sum of them. Okay. Okay. Now it equal to 100 won. Now we determine in the second step. The second step is close similarly to the first step, but we analyze at time infinity. At time infinity, when the switch is already changed the position, okay, and pressed in this position for a long time, what happened? You can see that the top branch is broken, right? If it's broken, it means it no current flow in them, okay? You can discuss them first, okay? And here, okay, we can, you know that this branch is already contract in here. You redraw them, okay, to make them more easy to observe, okay? Now, the 50 watt, you can see that new slot charging the capacitor, right? For time rate than 0, we use another slot, but now we use this slot, right? For time rate than 0, we use 120 watt charging this capacitor. For time infinity or time greater than 0, the 50 watt will be charging to this capacitor instead, okay? Now, you see that if the capacitor is full charge, it performs like open circuit again, okay? We assume any transient in the circuits die out long ago, leaving the purely DC circuit, and the capacitor acts like an open circuit to the DC current. Okay, you can see that this voltage is already contracted in here, right? Now, two of them, you can see that this resistor, 200 resistor, and the 50 ohm resistor, two of them is connected in parallel. You can combine them. Yes, you can combine them. Okay, combine them. The result equal to 40 ohm. Okay. Now the same as the previous, we see the capacitance voltage equal to the voltage across 40 ohm. Okay, and it's have one voltage source feed to two resistor. You can determine the voltage across 40 ohm by apply the voltage divider technique. Okay, the voltage divider is voltage across 40 ohm equal to 50 multiply with the resistance that contract to this voltage, okay, equal to multiply with 40, okay, and divide by the sum of them, okay, 40 plus 60, okay. Therefore, the result, the capacitance voltage at the time infinity equal to 20 volt, okay. Now for time greater than 0, for time greater than 0, the key of this chapter, this is how to determine the equivalent resistor. From the circuit, you consider for time greater than 0. For time greater than 0, the switch is already pressed in this position, right? And you can see that it still have some current source and voltage, it have some voltage source in here. You cannot see clearly what about how many resistor, okay, how many resistor to use in the equivalence resistor formula. You must kill source first, okay? How to kill the voltage source? You kill them by short circuit them, okay? And you kill the current source by open circuit, okay? After you short circuit them, what happened? You can see that you see them clearly, okay? Three resistor is connect in parallel. Connect in parallel. You can combine them, right? Parallels, okay? And the result equal to 24 ohm. Now, equivalent resistor equal to 24. You can see that. If you don't know how to combine them in this step, some is use 50, some is use 200, some is use 60. Wrong, all wrong, okay? That this thing is equal to 24, okay? Therefore, the time constant equal to 1.2. The general solutions form of the inductor and the RC, okay? The resistor capacitor circuit is shown in this formula, okay? We see, okay, the capacitor voltage at time infinity equal to 20, okay? Tau equal to 1.2, okay? You get here. Substitute them, you get here. But in this case, you can see that you still have one unknown in here. We had, right? We have, okay? Now, you can determine this unknown parameter by, you said, okay, the capacitor voltage for time less than 0 and capacitor voltage for time greater than 0, you set them equal. And you substitute every t to be 0, right? Okay? Anything power 0, give you 1. Therefore, in this case, you get, okay, 100 equal to 20. Therefore, V equal to minus 80. You substitute them back. The general form solutions of the capacitor voltage equal to 20 plus 80 e power minus 0.x3 t. Okay, and if the questions would like to ask you for more, such as here, is ask you for IC, derive them from VC. IC for time greater than 0, due to the VC for time greater than 0 is constant, it equal to 100 volt. Therefore, IC equal to C, derivative of V dt. But V is constant, its derivative equal to 0.2. Therefore, the capacitor current equal to 0. But for time greater than 0, for time greater than 0, the capacitor voltage is not 0. The capacitor voltage equal to 20 plus 80 E minus 0.x3 t. Okay, take derivative of them. Take derivative of 20 give you 0. Take derivative of 80 E minus 0.x t. Okay, give you EAT, give you A EAT. Okay, and you multiply them each term, you get here. Now, the questions ask you for more. In this case, it asks you for the current that flow in 200 ohm. 200 ohm. 200 ohm in here. For time greater than 0, it's easy, right? For time greater than 0, the switch is placed in the top position. Therefore, the current flow in 200 ohm is impacted by the inside loop, by the 51, 60, and 200. You determine I from Ohm's law. I equal to V 50 divided by our resistance 200 plus with 60. Give you here. It equal to about 0.19 amp. But for time greater than 0 is a little bit more complicated. For time greater than 0, derive everything in the term of VC. Remember that, in the term of VC. You kill this sort first. Kill this sort. You can see that. This voltage. You can see that we must derive I that flow in 200 ohm in the term of VC. You can see that the voltage across this equal to the voltage across this, right? Therefore, I erase them to emphasize what happened. The voltage across this terminal equal to VC. You know VC from the previous step. Therefore, I that flow in 200 ohm equal to VC divided by 200. The key parameter for RL, RC, or RLC circuit is you must determine the key parameter first. For RL circuit, you must determine IL, or the inductor current. For RC circuit, you must determine the capacitor voltage. And derive them from that parameter. Therefore, if you determine VC wrong, the rest is gone. Everything that you do after that lost in vain. Now, for the current flow in the 200 ohm equal to 0.1 plus 0.4 e power minus 8t. Now, in the overall point of view, what happened? In the overall point of view, for time greater than 0, the switch is placed in the top position. Therefore, it's a 120 volt will be supplied the energy to all remaining circuit, include it charging the capacitor until the capacitor is full charge. The capacitor is full charge and the voltage across the capacitor at the time equal to 100 volt. But for time equal to infinity, we have another source drive to your circuit. And the capacitor voltage will be dropped to be 20 volts soon. For time greater than 0, you know that, the voltage, the capacitor voltage will be dropped in the exponential form, due to the solution, the mathematical forms solution of the differential equation. Now you can determine the constant of them. Set the capacitor voltage for time greater than 0 and time greater than 0 is equal. You can get this value. Next one, if the questions ask you for the other parameters such as IC, IC you can determine them from the VC. For time greater than 0, VC is constant, IC is 0. IC is 0 because IC equal to C. Take derivative of constant, give you 0. For time greater than 0, it will become, IC equal to minus 3.3 e power minus 0.5 t. sorry, wait a minute. Not 0.5, not 0.5. Okay. Okay, 3.3, okay, e power minus 0.8 t, okay. And the last one, okay, the current flow in the resistor, okay. For time greater than 0, okay, is not affects, okay, this resistor does not contract to the capacitor, okay, it drive by the source and constantly. Therefore, the current flow into them equal to 0.19 amp, okay. For time greater than 0, it will be contract to the switch is pressed position and it forced the the resistance contract to the capacitor directly. Therefore, the voltage across them will be changed suddenly from 0.99 to be 0.5 amp, okay, and drop to be 0.1 soon, okay. You can see that the current and the voltage at every point in the circuit can change suddenly, okay, or gradually, we don't care. Only in this case, only the capacitance voltage that must change gradually, smooth, okay, step by step. If the capacitance voltage change suddenly, the current flow into the capacitor will be infinity, and it broken, it violates the physics law, okay. Okay. Your turn. Hello, can you see this? Anyone can listen me? Anyone can hear me?
Yes.
Okay, capture this question and solve it, okay, in 20 minutes, and I will provide you solution. Okay, I stop sharing the slide in 5 seconds. 4, 3, 2, 1. Okay. Okay. During this time, okay, I will check your attendance, okay. Oh, 33 students is attend, okay. Open the camera now to check your attendance. Hello, Jimma.
Hello, sir.
Can you copy the question already?
Yes.
Okay. Hi, Aswin. ไงบ้าง
อาจารย์ไปครับ
สิทธิพงษ์ธนพัฒน์ใช่ไหม
ครับมา
พัชรพันธ์
ครับ
ลอกโจทย์เสร็จแล้วใช่ไหมชนนิการเป็นไงบ้างทำได้ไหมลอกโจทย์ได้ไหม
ได้แล้วค่ะ
โอเค ชนติเป็นไงบ้างลอกโจทย์ยัง
ครับ
ตั้งใจทำนะ จะได้ผ่านหรือจะเอาเอเลยอะเทอมนี้นะชนติเอาเอเลยไหมตั้งใจทำก็มีสิทธิ์ได้นะ Oh, hello? Are you already finished? Okay, if you don't finish yet, okay, I will provide the solution of this and I will give you another one question, okay? At least, okay, if you do partial of them or maybe do all of them, you will get something, okay? A little bit deeper understand about this. Okay. Okay. Anyone can listen to me, right?
ผมเสร็จพอดีเลยครับอาจารย์แต่ผม
Okay.
ไม่แน่ใจครับ
Okay. Okay. The solution of this question is about here. Okay. The questions ask you to determine the circuit of this figure. Okay. And you can see that this circuit is okay. For this circuit is the inductor and the resistor and the inductor or the RL, the drive-in RL circuit case. Okay. For the drive-in RL circuit, you must determine the inductor current first. Okay, for the inductor current, okay, we do determine them in 4 steps. Okay, separate them in 4 main steps. The first one determine the inductor current for time less than 0. Okay, you can see that for time less than 0, okay, ut equal to 0. It means no short. Yes. Okay, if the circuit is have no short, okay, nothing in here, the current is the voltage at every point equal to 0 soon. Okay. Therefore, IL equal to 0. Yeah, IL equal to 0. Yeah, sorry, this 0. Okay. Okay, IL equal to 0. Okay. Now for time infinity. At time equal to infinity, this unit step equal to 1. Therefore, the voltage source change from 0 to be 20 volt immediately. Okay, at time equal to 0. And if the source is already charging the inductor for a long time, the inductor perform like short circuit. We assume in the transient in the circuits die out long ago, leaving the purely DC circuit. And the inductor act like the short circuit to the DC current. Yeah. The circuit now, after you short circuit this circuit, okay, short circuit the inductors, you can see that the circuit is comprised by the single voltage source and the single resistor. The inductor current equal to V divided by R, or 20 divided by 200. It equal to 0.1 or 100 milliamp. The next one is you determine the inductor's current for time greater than 0. Okay, you determine the equivalence inductor, equivalence resistor, you get the time constant. And after that, you substitute them in the inductor current in the general form. ILs, okay? You request to use, okay? You require to use the inductor's current at time infinity and time constant. At time infinity, it equal to 100 times, okay? At 100 milliamp. You can see that unit is milli, okay? And here, okay, the time constant equal to, okay, is equal to 0.02, or it's give you here. IL equal to 100 minus I equal minus 50 T milliamp. Now, for time greater than 0 and the time greater than 0, it equal when time equal to 0. For time greater than 0, okay, it have no source in here. The inductor current equal to 0. For time greater than 0, it equal to 10. Oh, sorry, 100 minus I equal minus 50, okay, milliamp, and time greater than 0 and time greater than 0, it equal, okay, at time equal to 0, e power 0 give you 1, okay. Therefore, the initial the constant in this case is give you 100. Therefore, the general solution in this case, I, the inductor current, equal to 100 minus 100 E minus 50 T milliamp. Okay. Now, if the questions ask you at time equal to 8 milliseconds, substitute them 8 milliseconds in here, you get 33 milliamp. Okay. And for time greater than, okay, for the questions ask you for more unknown, the inductor voltage, okay, you can determine the inductor voltage from the inductor current. And for time greater than 0, due to the inductor current equal to 0 and constantly, the inductor voltage equal to L di dt, differentiate constant give you 0, or the inductor's voltage equal to 0 for time less than 0. And for time greater than 0, okay, the inductor voltage equal to L di by dt, and the inductor current equal to 100 minus 100 E power minus 50t. In this case, we use, okay, 100 milli. Therefore, the voltage will be milli too. Okay. Now multiply them by here. Okay. Take derivative of 100. The first term give you 0. Take derivative of a EAT. Okay. It's here. E power AT give you A EAT, and A in this case equal to minus 50. Okay. After you simplify this form, you get here. Okay. Okay. The inductor voltage equals to 20 E minus 50 T. Okay, 50 T. Okay, and at time equal to exact millisecond. Okay, the inductor voltage equal to 13.4 volt. Okay, now in the overall point of view. Okay, what happened? Okay, for time less than 0, no sort is activated yet. Okay, therefore the current is 0. It makes sense, no sort. At time infinity, okay, the sort is already activated. Okay, and the current at time infinity will be reached to 0.1 or 100 milliamps soon. For time greater than 0, okay, the current will be try to increase, but it cannot increase suddenly. It will be increased gradually, step by step. Okay, you get this equation, and in this equation, it still have one unknown. This unknown, okay, I is an unknown. You can determine them from set the equations that get the inductor current from 1.3 and 1.1 is equal. When time equal to 0, you get this constant equal to 100. Therefore, in the fourth step, okay, you get the inductor current for complete form, okay, 100 minus 100 E minus 50t milliamp. And for time grade, okay, the questions ask you for the inductor voltage. The inductor voltage is for time less than 0 due to the current is fixed, okay, it's constant, okay. Derivative of constant give you 0, okay, the voltage is 0 too, okay. And for time greater than 0, okay, take the derivative of them will be the voltage will be jumped to be 20 volt and it will be dropped soon in the finery. Due to when the time is running, okay, the inductors will be full charge. If the inductor is full charge, it performs like short circuit at time infinity. And if short circuit, it means is that the inductor perform like short circuit is the current will be reached to the maximum point at that, okay, about 100 milliamp. Okay. Capture this question, okay, and try to use to solve them by your hand, okay. If you do by your hand, okay, it will be give you more understand, and the next time I will provide you complete solution. Okay, I think the way to give you complete solution will fulfill you about okay, the detail of the concept of the RL and the RC circuits. Okay, yeah. Capture them completely in 5, 4, 3, 2, 1. Okay, submit them. Okay, okay, capture them. Okay, and try to solve them in the next time. In the next lectures, I will give this solution first, and we go to the next part, the circuit that contain R, L, and C in a single framework. Okay. Any question?
Thank you, Ayan.
You're welcome. Okay, dismiss.
Thank you.
Come,